Number 10. How much force is applied to a 950 kilogram car that is rear-ended, causing its speed to change from 20 to 22.5 meters per second during a 0.65 second collision? So, first we're going to draw a diagram, then we're going to label our knowns and unknowns, then we're going to solve and see what we get. So first things first, draw a diagram. So the key is I draw before and after diagrams. And so what I do is I draw the car before it was hit. So before it was hit, it has a mass of 950. And it's got a velocity of 20 meters per second. So the initial velocity, VI, is 20. Then it collides. And when it collides, I just draw two parallel lines to show that there's a before and an after. When it collides, it applies some force from another object. We don't know what that is. And it does that for some time interval, which is 0.65 seconds. And then I draw the after. Here's a car. Now it's gotten its fender squished. There we go. Still got the same mass, but now it has a different velocity. VF equals 22.5 meters per second. Okay, label your knowns and unknowns. If you set up the picture like this, you don't need to do step B because I already labeled my knowns and unknowns in the picture. Otherwise, you'll need to list them. So VI is 20 meters per second. VF is 22.5 meters per second. Force is what we're solving for. Time interval is 0.65 seconds. And mass is 950 kilograms. So now we're ready to solve. So what equation are we using? Well, for all of these problems, we're going to use the same equation. F delta T equals delta P. Okay, but remember, delta P is always final minus initial. So what we're going to do is we're going to plug all the numbers in to these spots. So F is what I'm solving for, so we leave that as F. Delta T is up here, it's 0.65. But here's where we kind of get in trouble. We get to the delta P part, and we're not really sure what to do because we don't know the final momentum, and we don't know the initial momentum. The problem doesn't say anything about either of them. So, what do? We find those momentums using the other equation, P equals mv. So, off to the side, I'm going to find P final, and I'm going to find P initial. So, P final is mass times final velocity, so 950 times 22.5 initial momentum is mass times initial velocity, which is 950 times 20. So we solve those and see what we get. So 950 times 22.5 is 21,375. Okay, and 950 times 20 is 19,000. So then we plug in PF and PI. We found PF, 21,375, minus, so final minus initial is how we do delta P, so minus 19,000. So we get F times 0.65 equals 2,375. Divide both sides by divide both sides by 0.65. And we get the final force to be 3,653.8. And there you go. So some people don't like to solve these separately. Some people like to do them all at once. So another way you can do this is you can, instead of setting up that way, you can write it like this. F times 0.65 equals MV. So P final would be MV final. So you could write it as 950 times 22.5 minus PI 950 times 20. You'll get the same answer. It's just a different way to set it up. So if you don't like doing PF and PI separately and then plugging the numbers in, you can just plug in PF and PI, the values for them. So 950 times 22.5, 950 times 20. Either way, it will give you the same thing. Okay? Questions on how I solved that, what I did, what you're going to do, how you do it? Perfect. Okay, you're going to work on the practice. So let's take a look at that now real quick. I want you to start with number one. Number one is very similar to what we just did. The numbers are obviously different. The situation is a little different. But you're still solving for force. You're still given time interval, final velocity, initial velocity, and mass. So it's going to be similar things, even if it is a little bit different. That's what I want you to do first. Once you've done number one, move on to number two. But then once you've done two, I would jump to four. I would do 1, 2, 4, 3. That's the order I would do them in. Because 4 is a little bit different, and you'll probably want to be able to ask questions in case you have questions for me. And that way you can ask them to me while I'm here and able to go through it and help you. So I would do the order 1, 2, 4, 3. That's what I would do for the order. But I'm going to give you the rest of the period here to work. So you got plenty of time. Got plenty of time. Get as much done now as you can so you don't have very much to work on for next time. And that way you can just focus on figuring out what you want your project topic to be. And then hopefully just have that to do next time. If you need a calculator, you can come on up and borrow one. If you need to borrow one from me. But go ahead and get started there on the practice. See what you can do. And I will help you out.